Hello class, today we are going to look at functions, specifically wanting to know what functions are and what they are for. Now functions are basically built so that we can take a pattern and continue it. That's how I like to think of it. If we want to look at a more technical definition, we can look at the worksheet here. It says a relation is a rule that takes input values and assigns them to output values. A relation is a function if each input value has exactly one output value. Determine if the relation is a function. Below in the box under each relation, mark a check if the relation is a function or X if it's not a function. Okay. The whole reasoning behind creating a function is because we want some kind of relationship between one thing and another. So if I'm doing something as simple as buying a box of Cheerios, and the box of Cheerios is, say, $2.50. Okay, the relationship between how many Cheerios I buy and what it's going to cost for me to buy those Cheerios could be described with a function. Okay, where Y is what it costs me to buy the Cheerios and X is the number of Cheerios I'm buying. So Y would equal 2.5 times X. Okay, we set these up because in simple scenarios, maybe a function is not necessary if we know kind of the relation or the relationship. But many times we progress past simple relationships to more complicated ones, and a function helps us keep track of every little bit and thing that goes on in that relationship. Okay, and variables are just things that can change within that relationship, and that relationship can still hold true. Does that make sense? It's kind of like being in an actual relationship. At the start of the relationship, there's just two things, X and Y, you and that other person. But as your relationship with that person progresses, things could get more complicated. You could add things like children in, or family in, or money in your relationship, a house, a car, animals. Okay, and every little thing you add, it complicates that function and adds to that function. Okay, and in order for it to function, you and that person have to be within balance within that relationship. That X and Y in that relationship have to be within balance and coordinated with each other. Okay, and that's why we write all these things out within that function, so that if one thing changes with X, the corresponding thing can appropriately change with Y. Does that make sense? Hopefully it does a little bit. Okay, so let's see how this actually works with numbers. And we're going to start in a very basic sense here and give you some different graphs and tables and kind of work up to it. So if we look at number 1, in order for this relationship between X and Y to be a function, each input variable, which is your X is your input variable, okay, has to have exactly one output variable. Okay, so an input variable can't have more than one output variable. Okay, now on the contrary, an output variable can have more than one input variable. But we'll get to that example in just a second. So if we look at the first example, for X, 2 goes to negative 2, 3 goes to negative 3, 4 goes to negative 4, 5 goes to negative 5. Okay, this is a function, so we'll put a little check in the box because everything goes to one particular thing. That's an easy function. On the contrary, if we look at number 2 here, negative 4 goes to 5, negative 3 goes to 5, negative 3 goes to 1. This is not a function because now X has tried to step out of his relationship and go to 2 Y's. And we know that most of the time that doesn't work out. Okay, so this is a no-no because this same negative 3 is trying to have a 5 and a 1, and that's not okay in a function. All right, now number 3. We have coordinates instead of a graph or a chart here. So just remember, coordinates are set up as X, comma, Y. Right? Your first thing in the coordinate is your X. The second thing in the coordinate is Y. Now, if I look at this, all of my X's, I have a 2, a 1, a negative 1, and a 3. So I have no repeats in my X. If I look at my Y's, Okay, and I'll change the color for my y here just to make it easy to see. So we'll do y's in red. All my y's are also unique. If both are unique on both sides, then it's pretty clear to see that we do have a function. Okay, remember, we can only have one x go to one y. Okay, one x to one y. Now, like I said, there's a little caveat to this that we'll see in just a second. Now, if I look at number 4, here I have a 4, 5, 6, and then I have a second 6 in my x. And because I have a repeat here in my x, this is not a function. Okay. Now, when we come to number 5, our chart lays out 3, 6, and 9 for x, where the 3 goes to a 10, the 6 goes to a 15, and the 9 goes to a 15. There is a repeat, but in this case, it's a y. Now, like I said, there is a caveat to this. The caveat is the x's can't repeat, but the y's can. Okay, so it's okay if the y's repeat. So it's okay if the y's repeat, but not the x's. As long as the x's don't repeat, we're good. If the y's do repeat, it's okay. All right, and once we get down to the graphs, you'll kind of see why. All right, so number 5 is actually a function, even though the y's repeat. Number 5 is a function because none of our x's repeat. All right, if I look at number 6 and I look at my x column, I immediately see that we have a problem here because we have a repeat in our x column of this 10. So this is not a function. All right, number 7. Okay, if I go through my x's, I have -6, 2, 0, and 4. Because none of my x's repeat, this is a function. I don't even have to check my y's at this point. None of my x's repeat, therefore this is a function. Same here. Okay, x is a 10 here, 11 here, and a 12 here. Y is a -6, -5, and -4. This is as well a function. Okay. Now don't get the color scheme mixed up. They just did that for the worksheet, so they just alternated. So the circle colors or whatever don't mean that it's a function or not a function, because I know some of you are looking at the boxes, and so far every box that's been highlighted in gold has been a function, and every one that's not has not been a function. That is not how the color scheme works out on the worksheet. It's just what they did when they designed it. So don't let that freak you out. Number 8 is indeed a function. Now number 9, none of our x's repeat here, okay? Or do they? Now, with this chart, what we could tell is this -1 goes to the 0 and it goes to the 4. That's a repeat, because technically if I was to write this in coordinate points, this would be -1 and 0, and it would be -1 and -4. We do have a repeat in the x here, so this is not a function. Okay, so be careful with that. Now you can compare that back with number 5 here, where x's went to the same y's, but you can't have one x go to two y's, or multiple y's. Now, which moves us on to number 10. Here I have my x here of -30, 16, and 35. They all go to a 20 on the y. That's okay. It's still a function. I just can't repeat my x's. I can repeat my y's. All right. Number 11, if we look at the x, y table here, we want to try to make sure we don't have any repeats in our x's. But what I can see is I have a 6 here and a 6 here. One of them goes to a 2, the other one goes to a -2. Therefore, this is not a function. Number 12, I have a repeat of x right there. Both of them. Here's a 12 -3, and here's a 12 -4. Therefore, not a function. Okay, so let's hit on these ordered pairs just a little bit more and get a little more complicated and have a few more ordered pairs here. All right, keep in mind, once again, that with the ordered pairs, they're set up as x, y. I can't have any repeats in the x. Okay, so basically I'm just going to highlight all my x's here and see if I have any repeats. So I've got 10, -2, -6, 5, 8, and -11. I don't have any repeats, therefore this is a function. Number 2, I have -7, -8, -7. Oh, I had a repeat. This is not a function. Okay. Number 3, -13, 7, -13. Oh, this is not a function. Number 4, I've got 15, -6, -3, -1. This one is a function. Hopefully you could tell once you get the rule down that your x's can't repeat. It's never a good idea to repeat your x anyway. It never works out, right? As long as you don't repeat your x's, you're good. All right, -4, 5, 11, 9, 5. Oh, got to repeat. This is not a function. All right, number 6, 12, 15, 12. Got to repeat. This is not a function. It literally comes down to it being that simple. 6, -12, -6. Now, it's okay if it's negative because 6 and -6 are two different numbers. And 20. This one is a function. Okay. And number 8. -2, -8, -7, -2. Oh, this is not a function. All right, now let's look at it on a graph. Okay. Now, on a graph, you can see all these points are part of what would be your relationship. And we're going to see if these relationships are a function. Now, hopefully you recall something called the vertical line test. And the vertical line test is essentially a test that will tell you whether or not something is a function. And as long as you have it graphed, you can try the vertical line test. If it's points, you could try it with it. If it's a line or a curve, you can try it with it as well. Here we have points. What the vertical line test says is if anywhere on the graph you can draw a vertical line and never hit more than 1 point, then the relationship is a function. Now, if we go through here and we have even just one place where we hit more than 1 point, oh no, this is not a function. So because we had this mess up here where we hit 2 points right there, you can see the 2 points right there, because we have that mess up when we draw this vertical line, this whole thing's not a function. And it only takes one mess up. Okay? Only takes one vertical line that hits more than 1 point to go ahead and cancel out that relationship as a function. Does that make sense? All it takes is one mistake. That whole relationship that's a function is done. Okay? But if you can go through the whole graph and draw vertical lines anywhere and never hit more than 1 point, then you do have a function. Here a vertical line only hits 1 point. Here a vertical line only hits 1 point. Here a vertical line doesn't hit any points, and that's okay as well. But if you go through this whole thing, you can never draw a vertical line that hits more than 1 point. It's okay if it doesn't hit any point at all, but you can never draw a vertical line that hits more than 1 point. If that is the case, then this is going to be a function. Okay. All right, let's look at number 3. Now, if we eyeball this one a little bit, okay, we got a point here and here and here and here. Clearly, like I said, if we start drawing some vertical lines, I don't think you're ever going to hit more than 1 point. Doesn't look like it. Just 1 point. Here you hit no points, which is fine. Here's just 1 point. So this one as well passes the vertical line test, and therefore is a function. Makes sense, right? Hopefully it's making a little bit of sense. All right, let's look at the next worksheet, functions in a table. Okay, so this says state whether each table of values represents a function. Remember, all we have to check is that our x's don't repeat. If I look at table 1, I have no repeats in our x, therefore this is a function. If I look at number 2, I have a repeat here. They repeat the 9s, so this is not a function. Like I said, a function is just a relationship but it's a working relationship where nothing repeats. Okay. All right, if I look at number 3, I can already tell I have a repeat in my x, so this is not a function. Okay. All right, if I look at number 4, I'm looking at my x's, negative 15, negative 11, negative 14, negative 9, negative 1, negative 5. Hey, this is a function. I don't even have to look at my output y. My output y's don't even matter. All of these y's repeat, and it's okay if the y's repeat. But as long as the x's don't repeat, we're good to go. All right, I'll scroll down a bit. Got 2 more. Number 5. If I look through number 5, I'm just checking to see that the x's repeat. Okay, do I see any repeats within my x? I do not. Because there's no repeats, this entails a function. Okay. Number 6. I'm looking at number 6, and unfortunately I see a repeat here. Therefore, number 6 is not a function. And we're done for today. That's it. We've kind of learned what a function is. A function is a relationship where I have no repeats in my x, right? Think of it this way. If something is a function, it means it's functioning, right? Okay. You ever heard the thing? You ever heard the statement? You ever heard the statement? If you keep doing the wrong thing, you'll never get to the right thing, or something along those lines. That's kind of the way a function works, right? If you're putting in fresh inputs and getting fresh outputs, you're good. But if you keep repeating and putting in the same input and getting different outputs, something's not working. Does that make sense? So I shouldn't be able to put in a negative 3 and get a 7. And I shouldn't be able to put in a negative 3 and then somehow wind up the next time getting a 14. Okay? If you try one thing, it should always come out to one thing. Okay. Now you might try another thing and it comes out the same as what you tried the first time, but you shouldn't be able to put in one thing and it come out to 2 or 3 or 8 different answers. Okay. It's not functioning if you do that. For each input variable, you should only ever have one output variable. Now you might only have one output variable for all input variables, but for each input variable, you should only ever have one output variable. Okay, that'd be like going up to the register at Dollar General, having a shopping cart full of Code Red Mountain Dews. Those are your inputs. Each one of those inputs are the same thing, so they should render the same output when they scan them with the scanner. Now, I'm going to be really mad if I go up there to the register at the Dollar General and they scan the first Mountain Dew and it's $5, and they scan the second Mountain Dew and it's $7.50, and they scan the third Mountain Dew and it's $9, and they scan the fourth Mountain Dew and it's $4.50. See how that doesn't make sense? See how that doesn't function? That's not a function. You put one thing in, you should get one thing out. If I put a box of Cheerios in, it should always be $2.50 if $2.50 is the price. I shouldn't scan one Cheerio and it be $2.50 and then scan another Cheerio that's the exact same Cheerio and it be $5. Does that make sense? For one box. If I put a negative 3 in, I need to always get out a 7. I shouldn't put a negative 3 in and get out a 14 sometimes, and then sometimes get a 7. Okay? Put one thing in, you should always get one thing out. If I order a double quarter pounder with cheese, or a QPC as they now evidently call it, if I order a QPC at McDonald's, it should always cost the same thing every time I order it, especially within that same order. Okay? Put a QPC in, maybe it costs $6. That's what it should cost every time I order it. I shouldn't order 3 QPCs and one of them costs $6 and one of them costs $8 and then one of them costs $10. That makes no sense. That's not a function. That's not something that's functioning. Anyways, I hope it kind of makes a little bit of logical sense what a function is now and why we do certain checks to see if something is a function. We'll look into it more this week and engage more with functions this week. If you have any questions, don't hesitate to comment on this video or reach out to me via email or through Microsoft Teams. Y'all take care, and I'll see you next time.